The name of our project is Resolve Training Student-Centric Solvers with grpo-based reinforcement learning. In the first part, I will introduce the basic knowledge about our project and the algorithm. Firstly, what is the reinforcement learning? RL is a key branch of the machine learning and deep learning, where an agent learns optimal strategies through interactions with an environment. The agent executes actions in the environment and adjusts its behavior based on reward feedback, aiming to maximize long-term cumulative rewards. And then there are some core components of RL. Firstly, agent, the entity that executes actions and makes decisions. In LLMS, the agent is the language model itself, and then the environment and the state. And we will especially introduce state, the information describing the current situation of the environment. In language models, the state is typically the input prompt, and action is the operations that the agent can perform. In language models, actions are generated text sequences. Environment, the external world that the agent interacts with, providing state information and reward feedback. The reward is the immediate feedback signal from the environment to the agent's action, represented numerically to indicate the action quality. And finally, the policy is about a mapping function from states to actions that defines the agent's behavior rules. And then we will introduce about the objective IO, is to learn the optimal policy that maximizes the cumulative. And then there is the training loop of IO. The first step is to observe the state. The second step, execute action. The third step, receive reward. And the fourth step, update the policy. And the fifth step is iterated. It means repeats the process until the policy converges. And then I will introduce the algorithm which our project uses. It is grpo, which means Group Relatively Policy Optimization. First is a total overview. grpo is a simplified reinforcement learning algorithm that optimizes policies through group-wise relative comparisons, without requiring independent value networks or reward models. The core innovation of grpo is converting absolute reward values into group relative advantages, reducing dependence on precious reward estimation. And that is the core innovation. It is a relative advantage computation, and it uses absolute reward values or advantage functions. And the grpo will use group-wise relative ranking, reducing reward noise impact. And then it has a simplified architecture which is easy to train. And finally, the multi-reward function support. The support will combine multiple custom reward functions, and it can be flexibly adapted to different task requirements. And that's the first part of our project. In the next part, we will introduce about the training and evaluating our project.
Next, I'll share our grpo training project and the gsm8k math dataset. So, it's a collection of 8,500 grade school math problems. Seeing elementary school word problems, these aren't super complex, but they do require multiple steps of reasoning. And we use a standard split, about 7,417 3 problems for training and tested on 500 problems. One interesting thing about this dataset is the answer format. Models need to show their reasoning process and then mark the final answer with 4 hash symbols. And as for our model, we chose Queen 2.5, the 3 billion parameter version. It's small enough to run effectively but still pretty capable. Without any special training, it got 56.6% accuracy on our test set. Not bad, but there's still room for improvement. We use grpo, which stands for Group Relative Policy Optimization. It's a reinforcement learning method from the DeepSeek team. The idea is simple. For each problem, we generate multiple solutions, score them using reward functions, and learn from the comparisons. Our rewards are straightforward. Plus or minus 1 for correct answers, plus or minus 0.2 for following the format, and a small penalty if the answer is too short. Training setup was pretty standard. We used a learning rate of 5 times 10 to the negative 6, which is quite conservative for reinforcement learning. With 8 or 100 GPUs, we trained for just one epoch. We use several optimizations, BF16 per session to speed things up, flash attention 2 for efficient memory use, and gradient checkpointing so we could fit everything in memory. For each problem during training, the model generated 4 different attempts, which gave it variety to learn from. And for the results, let me first explain how we evaluate. We use the VLMM framework for inference with temperature 0 for grid coding, so outputs are consistent. Here's the evaluation process. The model generates a complex reasoning and answer. Then our evaluation code searches for the 4 hash symbols in the output and extracts the number of them as a predict answer. We then do an exact match between this predict number and the ground truth. If they match exactly, it's correct, otherwise it's wrong. Finally, we calculate the accuracy across 500 tested problems. And for the results, the baseline was 56.6%. After grpo training, we hit 86.6%. That's a 30 percentage point jump. Or if you look at it another way, we cut the error rate by more than half, from 43.4% down to just 30.4%. What's really cool about this is that we achieved this on a relatively small 3 billion parameter model. This shows that good training methods can make a huge difference, maybe even more than just throwing more parameters at this problem. And here is a concrete example. This is real data from our experiments. Here's a problem about Josh buying a house. Before training, the model's reasoning was almost correct. It correctly calculated the total cost as 130,000, the new value as 200,000, and even computed the profit as 17,000. But then, in the final step, it suddenly claims the profit is 30,000. This shows inconsistent reasoning. The calculation was right, but the conclusion was wrong. After grpo, look at the difference. The model now completes the entire reasoning chain correctly and consistently. Total cost 130,000, new value 200,000, profit 17,000. Every step is clear and correct. This shows grpo isn't just improving accuracy, it's teaching the model to maintain consistent and complete reasoning.
Dear teacher, for this part, I'd like to introduce Resolve, training student-centric solvers with GPL-based reinforcement learning, an AI problem-solving assistant focused on student needs. It supports 2 input methods, image upload and text entry. It can automatically recognize question content and generate step-by-step explanations to help students understand problem-solving logic with a current focus on subjects like mathematics. Well, our interface follows a simple and efficient design concept with 3 core sections. The top section shows the project title and the function overview, allowing everyone to understand the product positioning at a glance. The middle section uses a left-right column layout. The left is the input area where you can upload question images or enter text directly. And the right is the output area where the AI will gradually display the problem-solving process. This shows that we first show we're analyzing the question, and secondly, we show that we're generating solution approach, and finally, we show the solution in process, so that the students can learn from it to help them understand how to resolve the math problem. And the bottom section is an information panel containing function descriptions, supported subjects, and usage tips for quick onboarding. Well, next, I will demonstrate the core process. First, you can click the image upload area on the left to upload a clear image of the question, and the system will automatically recognize the text via OCR. Or you can directly paste the question into the text input box. After entering the question, clicking the Start Solving button, and the right side will load the AI's analyze process in real time. First, identifying the question type, then determining the solution method, and finally calculating step by step and giving the final answer. So if you need to re-enter, just click Clear Input. To try an example, click Example Questions to quickly populate the content. Well, our interface design has two core highlights. First, we used a purple-blue color scheme throughout, combined with card-style design, which is both professional and vibrant. Secondly, from the initial guide text to detailed usage tips, it reduces the operations throughout, allowing even first users to get started quickly.
In this section, I will briefly introduce the OCR model we are using. Our project not only takes text input but also image input for question reasoning, so we require another OCR model for text extraction from images. The model we selected is Paddle OCR. It's an advanced OCR optimized for industrial efficiency and speed. The architecture breaks the image-to-text conversion into two steps. The first step is text detection. This stage utilizes the DB algorithm. DB is highly efficient and responsible for precisely drawing bounding box around all text area. The second step is text recognition. This stage processes the text box using a CRNN-based structure to convert this imaging pixel into clean text strings. These two steps have three advantages. The first is outstanding accuracy. The precision of DB detector combined with the robust CRNN recognition is critical for correctly parsing complex question images. The second one is ultra-lightweight and high speed. The highly optimized design ensures rapid data processing efficiency, so we can process images instantly without creating a bottleneck. The third one is structural capability. It can handle complex layouts like tables, allowing us to feature-proof the project for more structured question formats. In summary, this specific architecture guarantees we get reliable, high-quality text data needed for successful reasoning. Now let's take a look at model performance. This is the GUI of our project. Let's start by testing the image input and the reasoning capability. Let's start solving. The process may need a few seconds. Okay, as you can see, the model extracted the text from the imaging and it provided a step-by-step reasoning analysis and yielded the correct answer. Let's test the text input directly. Start solving. Okay, you can see the complete solution. He also gives the detailed solution step by step and give you a final answer 10. Okay, that's all of our presentation. Thank you for listening.